All right, class, this is Dr. Frank Amankuna again, and this is the video for section 6.2. Now we're going to apply what we learned from section 6.1, that is finding the area under the standard normal using the table or the StatCrunch. So we're going to go straight into the applications of that. And like I said, it's very important to get these concepts very down because we're going to use it in the subsequent chapters that follow this chapter 6. Okay. So now, at the end of this is the learning objectives. We should be able to work with normal distributions that are not standard. They say they are normal distribution, they are not standard, meaning the mean is not 0 and then the standard deviation is not 1. So what do we do in that case? The second objective is that you should use a simple conversion formula that allow you to standardize any value of x, okay, so that you can use the same methods of the previous section to find the probabilities under the curve. So now, this is the formula starting from the second objective, that if I have the z-score that is converting x to a z-score is what is given by z is equal to x minus the population mean divided by the population standard deviation. And as you can see down here in these two diagrams, all right, so we are standardizing the x by using the formula that is converted into a z-score. Now, as you notice, the area P or the region P in both diagrams to the left and right are the same. So even though this says normally distributed with mean, it's not standardized. I can standardize it and use the table or use the StatCrunch, which I don't need to standardize if I use the software or a calculator. And so that is what we're going to do now. Let us look at the steps that we go through. Procedure for finding areas with non-standard normal distribution. The first thing I recommend for in this chapter is draw your density curve, the normal curve, and shade the area that corresponds to the desired probability. Okay, then once you know that this area is it to the right or to the left or is between two values, then we can use the standardized formula, the conversion, to find the z-score. Now, to convert it to the z-score, then as I told you, you can find the area corresponding to that, whether to the right, depends on what the question says, either to the left, it gives you the cumulative, or it is what's greater. So, the second thing is that we can also use the StatCrunch or technology or a calculator to do the same thing. So now I want to use the technology, as I mentioned, or the table to find the same everybody. So there are 3 steps that we can go to. Now here is an example. So what proportion of men are taller than 72 inches height requirement for shower heads? Okay, so we assume that normally men are taller than generally speaking. So what should be the percentage? So if the shower head is say 72, we want to know the number of men generally speaking whose height is what? Above the 72 inches mark. Okay, so to do that, we need to know, of course, we need to know the mean of this distribution. It's a normally distributed, and we need to know the standard deviation. So the mean is 68.6 inches and then 22.8 inches standard deviation respectively. So we want to find that percentage. Okay. So then how do we do this? here is the solution. First, I need to draw the curve. All right, that's my horizontal line, and that's my density what? Density curve, like that. Okay, now according to this, the mean is equal to what? 68. Not 68, it is 68.6. And the sigma, the sigma is 2.8 inches. So I go to my graph. Here's my 68, the mean, 68.6. All right, and that is that mark right there. And then to get a x, which is the 72 inches, then that is to the right. So 72 is somewhere there. All right. So we know the table gives me the area to the left of that. So let me use a different color. Okay. And I want to find the 72. And that. Erase this. Okay. Okay. So pick that pen again. All right. I want it's 68. Okay, so we have the pen and then 68.6 and then 72 on this side. Now our job is to find this shaded part. Okay, what is this area? All right, now the first step is that step one, we are using the table to find this probability. So I'm using the table. I'm using the table to find this. So table. All right. Then I need to find a z-score that corresponds to this, given by what? X minus the mu divided by what? Standard deviation. So this is what? 72 minus 68.6 divided by 2.8. Okay. Now, which is equal to 1.21. Okay, so I can draw this, I standardize it to mean that the mean, okay, is now what? 0, and this value here is 1.21. Okay, so then I go to the table. That's my step 2. Step 2, I go to the table and then find this probability, 1.21, cumulative to the right. But remember, this is the probability that I'm looking for. The z is greater, right, than 1.21. This is equal to the 1 minus the probability that it is less than what? Less than equal to 1.21. Okay, that is a, remember we did a, what do you call it? The, the complementary what rule that we learned in chapters 4, right? So now, what is this probability? So I can go to the table and do that. So let me share my screen with you. I want to get to the table, so I'm going to do my, okay, I start, go to my table. So here's the start crunch. I mean, there's homework, which I'll come back to and solve one of the problems in a minute. So I'm using the table, all right, and then I'm looking for 1.2 under what? 1, so 1.21, and that probability is what? That probability is what? 0.8869. 0.8869. Okay, so if I go back to my screen, right? Now, this probability is equal to 1 minus 0.8869. And when I subtract, I get 0.1131. Okay, so this is my probability. So it means that 11%, actually 11.31% of the men, okay, are taller than what? 72 inches for the shower height requirement in the US. Okay, so how do I use the start crunch to give me the same thing? Now I told you to use the start crunch, I don't need this step at all. I don't need that step. All that I need is I know my mean and know my standard deviation. Okay, sorry, this is my X. I know my X is 72. My standard deviation is 2.8. That's all that I need. So let's go and do that. Okay. So I go back and share my start crunch. Okay, so here is my start crunch. How do we get to this point? Okay, you go to start, calculators, and I pick normal distribution. Okay, and then I said, I don't need the standard by default, the mean is 0, the standard deviation is 1. That's a standard normal. But this says it's normal, so I'm not standardizing it. I put my mean 68.6, and then my standard deviation is 2.8. Now, remember, I'm looking for probability to the right, that is men taller than 72 inches. Okay, then this inequality is less than. This will give me the probability that I got. That is, if I don't standardize it, I get 0.8877. Okay, but if I standardize it, okay, if I standardize it, that's be a different, but the difference will be just very, very small. So I'm just showing you that if I don't standardize it, I get this. So if I change this to greater than, now you see that probability, it is 0.1123. Now this probability, you see that we got 11.31 and we are getting 11.23. There isn't much difference. Okay, I want you to know that. Now, if I standardize it, okay, let's see if we get the same thing. Okay, the mean is 0 and standard deviation is what? 1. Now, what's my z-score? It is 1.21. Let's see what we got. See that this is exactly the same table value we got, 11.31. All right, so what is happening is that if I don't standardize it, I will get the same answer, but the difference won't be exact because it's computed. All right. Now remember, when you standardize, you run off the what? The z-score to 2 decimal places. And note that whenever you do that, okay, whenever you do that, you are what? You are creating an error. Okay. So let's just note that. Now let us go back to our presentation. So the solution is that, remember, I'm using 11.21 because when I use without the standardizing, I got 11.323. But when I use a table, I got 11.31. So, which is the same, depending on which one you use. But again, the difference doesn't really matter. And for your homework on the exam, it gives you a margin of error. Since if the answer is this, they'll say that plus or minus okay. So let's continue with that. And let's go with my raw point, which is right here. Show that. All right, so that's where we left off. So remember that. Okay. So now let us go to the next example. Okay. So here we are going backwards. If I know the z-score, now before I go on, let me do one example in the homework problem. Problem number, okay, problem number 4, okay, the homework problem. Okay, the homework problem number 4. Okay, let's do that in a minute. Let me show you how. So I'll go back to my homework. Let me put that. Oh, I'll pick a on screen. You pick that up right here. All right. So now, if I want to do my homework, say homework here is it. Let's do question number 4. Okay. Question number 4. All right. So as you can see, here's I want to find the x value. Okay. In fact, this comes after what I was going to do. Actually, let me. Okay, I'll come back to this. So let me go back to my presentation. Okay, I was ahead of myself. All right, so that is, we'll come back to the homework. So just a minute. So here is the inverse. Now this example, the example for homework follows after this. I was ahead of myself. So you want to find the x value that given a probability. As always, sketch the normal distribution density curve. Okay, and then you can use a table and then the start crunch, right, to find the what, the area. Now, once I do that, step 3 is that I can use this formula to find the x value. Okay, so this is the formula that is the mu equal, so x is equal to mu plus what, this the z-score times what, your sigma. Okay, if I use a table, I'll need that. If I don't use a table, I can still get the z-score from this start crunch and then use this formula to find the x value. So here is the example that I was talking about. So now let's just go back to our, okay, to our homework. Right here. Okay. So here is the homework, question 4 of your homework. Now here is the, you want to find the x value. Okay. Then you want to find given the area. So this is given to us, so it's easy. I just know the area. So the question is, what is the z-score for that? What is the z-score? So let's try this. A different, I've already solved that. So let's try another question. What's the z-score? If I know the z-score, then I can find the x value. Right, this is the area. So it means that what is the area to the left of that? Okay. What's the area to the left of this? Okay. So I want to find the area to the left of that. So let's share my screen. that. To see that. Okay, so here's the question. So how do I find the X value? Okay. Now notice that we are given the area to the right is what? 0.1431. 0.1431. Okay, so I'm going to solve that for you. Let me go and share my whiteboard. Okay. Now, let me move this here. So let me go back to my PowerPoint. I think that should be better. Just going to share my PowerPoint. So here is it. Now, the question we had was that we had this was the given. And then they have this area as 0.1431. Okay, and we want to find the X value, which we don't know. Okay, so if I go to the table, if this is 1.5, what is this area to the left of this? Okay, what is this area? So I subtract this from 1.1431. Okay, and that area is 1 minus 0.1431. Okay, 1 minus 1.1431. That area is actually 0.8569. So I go to the table and look for a value that is what closest to that. Okay, something closest to on this. Or if I get fortunate, I'll find it exact value. And that find a z-score that corresponds to that. So let's go to share okay. So I'm going to pick a table. It says from, let me pick the table from here so that you can see what I did. Okay, I'm looking for, in the body of the table, I'm looking for 0.8569. 0.8569. Okay, well, I have 0.85. I have 85, 85, 5559, 8577. Okay, I'm looking for 8569. 8569. So which of these values is closest to the value that I have? Now, as you can see, right, maybe this one is. So let's subtract 0.8577 minus 0.8569. Okay, it is 0.0004, so 8. And then the other one is the one the closest is 0.8554. So 0.8569 minus 0.8554. Okay, which is 0.0018. So the closest to this value is what? 0.8577. Okay, so that means that what is the z-score? The z-score is 1.85 1.07. 1.07. Okay, so let's minimize this. Okay, and let's share our PowerPoint. Okay, so we got the z-score that corresponds to this value here. Okay, corresponds to this. Corresponds to that is 1.07. So that's the z-score is equal to this. So now, what we need to do is that we have the z-score to be this. Then what is the x value? Okay, so my x is equal to mu plus the z times sigma. Now, according to that question we have there, okay, let's go back to our homework so that we can see what that value was. Okay. So question 4, I'm hoping it's not a different one. Okay, the standard deviation, the mean is 100, standard deviation is 15. Okay, mean is 100, standard deviation is what, 15. So now let's just minimize this and share our PowerPoint. Okay, so it means that we have the mean is 100 plus standard deviation is 15. 15 times the z. Let me erase this quickly. Something right here. Let's pick up pen again. So the z-score is 1.07 times the standard deviation is 15. Okay, so this gives us 100 plus, okay, 1.07 times 1.5. That is 16.05. 16.05. 16.05. Okay, so that will give us 116.05. The question says run it to the nearest what? Whole number. So it is 116. Okay, that will be our answer. All right. So now let's just go back to the to the homework and then enter that value. Let's see here. Okay. So what's the key? S2 is what? 116. And we got the answer correct. Very good. So now I'm going to take other examples, okay, where I'll show you how to find. So here's a question. All right. It said, designing aircraft cockpits. When designing equipment, one common criterion is to use a design that accommodates 95% of the population. Okay, we have seen that only 46 of women satisfy the height requirements for US Air Force pilots. What would be the maximum acceptable height of a woman if the requirements were changed to allow the shortest 95% of women to be pilots? What does that mean? That is, find the 95th percentile of heights of women. Now, when saying 95th percentile, you want to find the value so that 95% of the population is less than that, and only 5% is above it. Now, it said, assume that the mean, okay, the mean is what? 63.7, and then the standard deviation is what? 2.9, and is normally distributed. So what is this value, and how do we calculate that? Well, here is the approach, okay? The figure shows the normal distribution with the height x is this. So the question is that, we are looking for the x value, so that we have 95%, that is 0.95 to the left of it, okay, as you can see this part, and then with a mean of 63.7 and a standard deviation of 2.9. So the question I need to answer is that I'm going to use the StatCrunch to do this one, okay, to find the x value. I'm not going to convert it to z-score, but I need to know this value. So the question is, how do I get this value? Now let us go to StatCrunch and to do the same thing. So I go back to my StatCrunch. Okay. Now again, how do I get to this? Go to Stat, Calculators, Normal Distribution. Okay. Now according to this, what was the mean? The mean was 63.7, I believe. And then the standard deviation was what? 2.9. All right. Now we want to find the cumulative probability so that we have 95% to the left. So that's the z-score that I want. Okay. This, when I don't convert, all right, it gives me the value that I really want, the x value. However, this is not the z. I want to use the formula. So what I need to do is that I need to change this to what? 0. The mean is 0. I need to standardize, and then that is 1. But the probability is the same to the left, and then let's compute that. Now you see that we got 1.645. 1.645. I can use the table to find the same thing, which we did in 6.1. That's why I'm not doing that. So the z value is 0.645 to 3 decimal places in this case, because that value falls within 1.64 and 1.65. When you take the average, it gives you that value. Very good. Now, let us go back to our PowerPoint, okay, and then answer the question. That's why I got this point where this is my z-score. So I'm going to use the formula to find that. Okay, I'm going to use the formula to find this. So I use the technology, okay, and then this says that my z is equal to 1.645. All right, and then I know my mean is was 63.7, and the sigma is what? 2.9. So I'm going to find the x value using the formula. The x is equal to the mean, okay, which is 63.7 plus, okay, got two values there. My z-score is, okay, let me look. I think I was saying something myself. Okay. Let's pick up the pen again. So I have what? 1.645 times 2.9. Now, when you evaluate this, you will get 68.54 inches. Okay, 0.5 inches. So it means that when you have this, the diagram that we drew, okay, so that you have -0.95 to the left of that, this value x is what? 68.54 inches. So this allows me to say that if you have the woman height set to this limit, okay, 5% of the women will be above that, and then you have 95 of the women will be as part of what F4. So to be Air Force pilot. Because that was a question that if you have this, what is the minimum or what's the maximum value of the height, allowable height? So we just got that. And so that's why we have this answer. So the step 4 says that the solution of the x equal to is reasonable because it is greater than what the mean of what 63.7 inches, because it allows more women to be what Air Force pilots. Okay, so what's the interpretation? The requirement of a height less than this will allow 95% of the women to be eligible. Okay, there should be a minimum height requirement so that the pilot can easily reach all the controls. Very important. So statistics does a lot of work and help us to make decisions, and so that we don't waste or deprive a lot of people to be part of a certain group in our military. Okay, so here's another example. It says that it's a body temperature. Based on the sample results in data set body temperature in Appendix B in the book, assume that the human body temperature is normally distributed. The mean is 98.2 degrees Fahrenheit, and the standard deviation is 0.62 degrees Fahrenheit. Okay, so our question are 2 parts. Now, if I have, according to the emedicinehealth.com, a body temperature of 100.4 degrees Fahrenheit or above is considered to have a fever. So somebody has this temperature. We don't know that for coronavirus yet, but this is from this website. So if they know that this has fever, then the doctors can decide to have further tests and to look for other things why that is causing the high fever. So the question is, what percentage of normal or healthy persons will be considered to have a fever? Maybe this value is too high, or maybe it's too low. Okay. In other words, that this percentage suggests that a cutoff of this value, 100.4 degrees Fahrenheit, is appropriate. So we want to answer that question. What should I do? Okay, I need to find, in this one I'll use a table. So first, I want to find my what? Let me draw my sketch, very important, okay? So you have your sketch, right? Okay, now the mean is what? 98.2. 98.2. And then you want to find the temperature of what? 100.4. Now, what is this area? Okay, that's what we are looking for. So I need to get my z-score, which is what? 100.4 minus 98.2 divided by 0.62. Now I need to calculate the z-score. When I did that, this is equal to 3.55. Okay, 3.55. So I need to find the probability that corresponds to this z-score using the table. Now, if you use a table, you'll notice something. Okay, so let me show you. Okay, let's see. Okay. So let's go and get this value from the table. All right. So What are we looking for? 3.55. Now let us look at the positive part of the table. 3.55, scroll all the way down. 3.50 under 0 is what? 0.999. That is cumulative area to the left. So anything more than 3.5 is 0.999 according to the table. Okay. So if you want to find the area to the right, then you have to subtract this 0.9999 from 1. Okay, to get that probability. What we do, you get 0.00001. In other words, you have only 0.01% of the people, okay, who have this, who have considered to have what normal people to consider to have what high fever or has fever, and therefore something must be done. Okay, and it is appropriate. It is not into me because only about 0.01%, okay, only about 0.01% of the people. Okay. So now let's go back and respond to that. Let's go back to our PowerPoint. Okay. So the question is that this probability, okay, what's my pen? The probability that the Z is less than or equal to 3.55 is 0.9999. So if I subtract this from that, okay, I get 0.00001, which is the same as 0.01%. Okay, so that is the answer to that. Now the second part, I want to use StatCrunch. Okay, says that physicians want to select a minimum temperature for requiring further medical tests. What should that temperature be if we want 2% of healthy people to exceed that number instead of 0.01%? Okay, that's very, so what we do is that we want 0.01% to this area to be 0.02. So what's the area to the left of that? Okay, this is 0.998. Sorry, it's 0.98 like that. Okay. So now, if I use the StatCrunch, I want to find that probability. The question is that, what is this value? What is this value? X. What's that value? X. Now, I can use the StatCrunch without converting it to a Z-score because I'm not using the table. So I'm going to do that. So let's share the screen. Go to my StatCrunch. Okay. Now, this time, I'm putting the mean of that is 198.2, and the standard deviation is 0.62. All right. I want the probability to the right to be 0.02. Only 2% of the normal people will exceed that temperature. So what is that temperature? Okay, I put it here and change this to what? Greater than. Oh. 0.02. Okay. All right, so look at that value. If you run it to one decimal place, that is what? 99.5%. So let's go back. Okay. So 99, when we calculated that, this is what? My X is equal to 99.54%. Okay. So that answers that question. Now, here is a similar, what do you call it? A similar problem. This time, we want to find, for engineers, right? Is that engineers want to design seats in commercial aircraft so that they are wide enough to fit 90% of all males. Okay, accommodating 100% of males will require very wide seats. That will be much too expensive. Men have hip breadth that are normally distributed with mean 14.6 inches and a standard deviation of 1.4 inches. We want to find the upper 90 percentile. Now note that this value here is not Z alpha, because if it's Z alpha, then we want the 90% to the right and then 10% to the left. But this is percentile, meaning that you have 90% of the people less than this value, percentile value to the left, and only 10% above. Okay, so if I want to do this, okay, if you want to do that, we have this same body temperature. This time, we have Z, the mean is equal to 14.6. The standard deviation is 1.4. Okay, and then you need to sketch your density curve, right? I want to find that X value, right? So that this is what? 1.10%. And to the left is what? 0.9%. 0.90%. Okay, so I have 0.90% for that, or 90%. Okay, so now the question is that, how do I get this S value? This time, let me use the table. So it means that I need to find a Z-score that corresponds to this. All right, you have 90% to the left, and what is the Z value that gives me? Then I can use the formula, X is equal to what? The mu plus comparison Z times what? Sigma. Let's pen sometimes. Let's go back. Okay, so let's write everything here again. Oh. Let's go back. Okay, so we have this. Let's fix this and that. Let's pick the pen. All right. So now I want this area. This area is what? 0.1, and this is 0.9. That one is Z, which we don't know. Okay, but I can find a Z. I know my Z. If I know the Z score for this, then I can use the formula X is equal to the mu you can find the mu plus Z times what? Sigma. All right, this is Z. So this is X not Z. This is X equal to that. Oh man, the pen is messing up. Let's go back. So you have X equal to mu plus sigma times that. So I go to the table and find that value, which will get to show that and pick my table. All right. So how do I get my value? I have my Z. What's the Z score for that? because we don't know. So I want 90% to the left. So 90%. So go to the table. I'm looking for 0.90, 0.90, 0.90, 0.90. Well, 0.90 is closer here. We have 0.8997 and then 0.9015. You see that 0.8997 is closest. So this value is actually what? 1.28. Sorry, 1.28. 1.28. So if I go back and share my PowerPoint, right? So then I can find that value. Okay. So this is what 1.28. So what is the x? X is equal to the mean was 14.6 plus the z is 1.28 times sigma, which is 1.4. Let's go back and check. Yeah, 1.4 and 14.6. 1.4. Okay, so let's evaluate that. So this is 14.6 plus 1.28 times 1.4. Okay, so everything is for 16.392. So to do the approximately to one decimal place will be 16.1.4. That is being my value. Okay, so that brings us to the end of this section, and I hope this is helpful. All right. I will see you. So let's end.